Hi girls. Now I don't have my whiteboard to write on today, so what I do have is a little mini whiteboard, and I'm just going to move on to the next part of this chapter, which is called definite integrals. So with these ones, sorry, this is on page 77. With these questions, up till now, whenever we've integrated something, we've added c on. With these, we don't have to do that. That's explained on page 77 to 78. But basically, you're going to be given what's called two limits with these, and I'm just going to go ahead and show you how to do one. But before I do, what I want you to look at is page 77 and on to 78. Because what they are trying to show you here, that by integrating between two values, you are able to find the area between a curve or a line and the x-axis. So it's a really useful thing. So on page 77, they gave you can see a little diagram of a triangle, 3 out, 3 up. The line there is y is equal to x. But if you were to go about finding the area of that, normally you do half the base by the perpendicular height, half 3 by 3, which is 4.5 square units. What they go on to do then is they show you that you can also do this with integration. And this is one of the applications of integration, is to be able to find the area under a curve or a line, okay, between 2 points. So they go through explaining it all, and you can have a look at that before maybe you have a look what I'm going to talk about here. But what I'm going to be looking at is basically on the next page, page 78, you can see there's two yellow boxes. One of them have the area enclosed between the curve y equals fx, the x-axis, and the lines x equals a and x equals b is given by, and the area is that. But what this can also be written as, and what we're going to be doing is, instead of looking at the graphs, we'll look at them later on. Let's just get to know how to actually do the process of this. Is if you integrate between, as you can see, this b and a are going to be numbers between two values. What you do is you integrate it and then you sub in those values, and that actually integrates a specific area of a graph. Okay, now I'm just going to do the very first one on page 79. So the first one asks you to evaluate the definite integrals in numbers 1 to 15. The first one is just this: integrate 6x, okay? And then you can see the 2 and the 1. I'm going to show you what you're going to do with them. They're your two limits, okay? So if we first start by just integrating 6x, we will be getting 6x. We'll be increasing our power by 1, so it will be squared over 2. And usually then what you would do is you would plus c on, but you do not need to, and that's actually, sorry, explained on page 78 if you want to look at why. But when you're given limits with these, you don't actually need to, by limits, by the way, I mean this 2 and this 1, you don't actually need to put the c in, okay? But what you do need to do is this: put a little bracket in, because what we're going to do now is we're going to be subbing the 2 and the 1 in, and I'm going to show you how you do that. Again, it's on page 78. You'll be taking one bit away from the other, okay? So how to finish that off then is, well, firstly what I might do, sorry, is the 6 over the 2. I'm going to simplify that to 3. So 3x squared, and between those two limits there, okay? So if I go and do this then, I'm going to sub in 3, 2 is going to go in place of x, and then minus 1 will go in place of x. I'm just going to show you what I've done so you can see it. So it's going to be, you can see the top one, the top x value has been subbed in here in place of x, and then minus the bottom x value has been subbed in there. Okay, now if you go about working them out, you get 3 by 2 squared. So 2 squared is 4, 4 by 3 is 12, minus 3 by 1 squared, which is 3. And that gives you a total of 9. Okay, and what you can call this, I don't know what way they have them in the back, Just trying to think, do they just have, no, they just have the numbers. I was going to say, if you were dealing with area here, you could call it units squared. But you're just getting an answer of 9 there, okay? So I suppose the difference here is you will be given these, they're called limits of integration, these numbers here, okay? And these are basically, with one like this, we're trying to find the area. If we were to like have a look at this as a kind of, as a on a graph, we're trying to find the area, and we're going to deal with that later on, but I just want us to get to know the process of it. We'll be finding the area under the curve or the line of that. So what you do with this is you integrate your function here, and then as you can see, these two numbers then get subbed in. The top one goes there, and then it's minus the bottom one there, and you end up with an answer of that, okay? So what you are going to do for me now is, so this is the first half of the double, is that's 1 done. You're going to do 2, you're going to do 3, you're going to do 4, you're going to do 5, and you're going to do 6, okay? Just getting practice with these. And then you're going to do 7, and this is on to the next page, and 8, and 9. Okay, I'd say that will do us for the first of this double, okay? So if you do 1 up as far as 9. Now, if you get them done, you can go on and do up as far as, let's say, 15, okay? Do as many of them as you can, because what you'll notice is, if I just look at question 1 to 6, they're straightforward enough once you know what you're doing. But when you move on to from about 8 onwards, you're going to be using index rules there, because remember, with integration and differentiation, they have to be written a certain way for you to be able to do them. What I mean by that is, you can't integrate or differentiate a square root. You will have to turn the square root of whatever it is into the power of a half. You can't integrate with 1 over x squared. You would have to use the index rule to bring that x squared up and make it become x to the power of -2, for example, okay? Right, you get started on them and let me know if you're having any issues with them, okay? Best of luck.